Welcome again, everyone. And we're going to start the day now. Some bit of information for you before we start. We'll have 7 speakers on this stage today, all outstanding speakers in the field. So we're looking forward to a very exciting second day for this year's Hacktivity. Just before that, some practical information. For those of you who are hungry or thirsty, on the first floor, you can go to the Vodafone Shared Service Center stand, and if you fill the hacker quiz, you're in for a free pogača. So just you can have some free good food there. And also, if you're thirsty, you can go to the leisure zone here on the ground floor, where at the RRC stand you can get a free glass that you can switch to beers or juice. And thirdly, for anyone who's looking for jobs, you can send your CV to cv@hacktivity.com until next Sunday, that's the 21st of October. And then your CVs are going to be forwarded to any sponsors of Hacktivity who have job offers, and there are some serious job offers out there, so I suggest you do that. And beside the opportunity to get jobs, you can also win one of the 10 tickets to next year's Hacktivity if you send in your CV, so I suggest you do that. And now on to the program. Our first speaker is László Biró, who is a regular speaker at Hacktivities. He always has an exciting topic that is worth thinking about, but he's not only professional in IT stuff. If you have an electric or a Hammond organ that needs to be repaired, you can also drop him an email and he's going to do that. And while he's working on it, he may tell you some impressive stories about the good old times of IT. So today, he's going to talk about the alternative internet. That is what happens if communication centers and telecommunication providers are somehow lost. Can we provide any alternative networks that we can use for having an internet? So welcome, the floor is yours.
Good morning. As I can see, it's very Saturday morning. I also hate mornings. So, we would like to talk about a secondary way how we can provide information for customers. Information assurance it's more than collecting the information, it's more than organize it. Finally, the end users must have that information, so we have to ensure the availability and the distribution of information too. Now, I would like to deal with the distribution. There are old ways for information distributions. The speed was limited. It needs special knowledge decoding the signs, so it's not the best way for information distribution. Later, there were some wired and wireless ways, and both of them have some benefits and disadvantages. So the very first method was the wired communication. They tried to use it for voice and for digital data in the 18th century. The voice transfer was a bit fussy because the range was short, the quality was very weak, and the reliability also was very weak. The first digital transfer was the telegraphy. It was fairly reliable because the data speed was very low, so it was easy to correct it. The quality was fairly good, and the range at the first attempt was more than 60 miles. In that time, in 1868, it was a very, very, very long range. It was easy to implement it to wireless environment. An early method was the spark telegraphy. Everybody has heard about the Titanic. Titanic used the spark telegraphy station, and you can see the waveform of that signal. This is the letter C. That time, the emergency call was not the well-known SOS, but the CQD. So they transmitted that signal. Voice communication was a bit different because first the engineers had to provide an unattenuated signal, a continuous sine wave signal. And until developing the first electronic tube, the vacuum tube, it was impossible. The problems was solved by two engineers, Liebens and de Forest, and then the voice communication and the radio broadcasting started. According to the targets of the communication, we can talk about one-to-one personal, military, traffic, intelligence, and so on, one-to-group communication and broadcasting. In the broadcasting, there is a special Hungarian aspect. Puskás Tivadar, he invented a special sort of phone exchange, which was able to distribute news for every subscribers. It was in 1886, as I remember. So it was very new. A couple of years ago, we were in Cork in Ireland, and the Cork Telecommunication Museum, there was a photograph about that sort of telephone hírmondó. The wired communication is perfect for one-to-one communication and one-to-group communication, but it's not so good if you want to broadcast something. One-to-one communication, phone call, mobile call, encrypted digital signal, radio conversation, email, Skype, you know them. Group communication, group mails, conference calls via Skype. But the last one is connected to the internet. That means that internet brought a new way of broadcasting information, and that means that internet brought a new chance to organize things. Broadcasting, it was mainly for news, for entertainment, and radio and TV broadcasts was sufficient for do that. But internet gave a new way, web pages accessible with browsers. Internet is very popular, so nowadays everybody can use a browser, everybody can use a mail client, so accessing broadcasted information via internet starts to be more important than the conventional ways. But someone somewhere tries to control the information broadcasted. If you want to control something, you must have control on the media broadcast that information. If you try to control something, it will be vulnerable because the control point will be the central point of vulnerability. So the more controllable is an information source, it's more vulnerable. Some purposes of communication, news, entertainment, and so on. The last one is, I would say, based on the internet technology. Emergency communication. Service providers try to fulfill your requirements, try to ensure the communication, but it's vulnerable because it's based on central points. portable mobile radio and CB, unreliable, short range, special device, and it's easy to bypass, easy to make that way inoperable. So not a real emergency communication. Military communication is reliable, but special devices, special knowledge, limited accessibility. And the last one, the ham stations. Radio amateurs are known about building machines, operating machines, building special devices for fast communication, for long-range communication, and they have the knowledge and they have the will to do something. So an ideal group for voluntary operation. An interesting ham station in California, a couple of years ago I was there, and between Palm Springs and the Pacific Ocean there is a high mountain, and on the top there was a ranger station, and they had several communication units, phone and semi-military units and so on, and they had a ham station, and I asked them why, and they said that it can work in every situation. Reliable, long range, it can work without mains, can be compatible with the military systems. The only negative thing is it needs a special ham knowledge, the amateur knowledge, but it's not a big deal. In Hungary, in 1970, there was a terrible flood in the northern part of Hungary, and the phone infrastructure was washed away. And we gave a radio grid with that small units, 10 watts of radiated power, and it could replace the whole telecommunicational service. So, some information to compare the radio grid and the internet-based technology. You can see the radio grids have some very interesting and valuable pros. So we should combine the two ways if we want to build a durable and reliable emergency communication. In the first step, we have to teach the radio to communicate digitally. It's very easy because, as I told before, the telegraphy was a digital method because letters was converted to dots and dashes. One dash is 3 dots, so it's a clear digital way. Then, with the radio, we can ensure in the OC system the layer 1 and layer 2. So, if you have a radio and connect it to a computer, you can build a stable, reliable layer 1, layer 2 communication. Then, the only thing you have to do implement a protocol. X25 is a well-known communication protocol. In the first time of the networking, it was very popular. Nowadays, ATMs use X25, but in the internet technology, the TCP technology is washed away the general use of X25. So it went to the amateur praxis. AX25 is the amateur version of the X25. The only difference is the quality of service is not implemented. You could buy X25 modems, you can connect it to your PC and the radio, but it was very pricey a bit large. So that was the technology, the amateur digital technology of the 1970s. Later, you could buy transceivers, two-way radios with built-in X25 capability with immediate connection to the PC. But it was also a bit pricey. But what does the modem do? The modem converts the bit stream to combination of voices. Is there any other tool for this purpose? The sound card. So later in the 1990s, the modem function is solved with the sound card of the PC, inexpensive, flexible, and there were several homebrew solutions. An early version, you can see with Windows, the famous Windows 95 on the famous DX2. So not so resource intensive solution, and it worked. How does it work? You need a special driver. You have to hijack the traffic, aim the serial port, and redirect it to the sound card. The sound card has a synthesizer circuit, and it can generate the voice mixes, the sound mixes, which can transfer the bit combination. The headphone output of the PC is connected to the mic input of the transceiver, and the headphone output of the receiver part will be connected to the line input of the sound card. The received sound mixture will be decoded by a fast Fourier transformation, and the bit string will be available virtually on the serial port. The AX25 protocol will run in the background. What's happened? In 1996, the AX25 network in Hungary, 1998, repeaters. If you increase the frequency of the transmitting signal, your bandwidth, available bandwidth will be higher. So amateurs moved from short wave to the 2-meter band and to the 70 centimeter band. But if you increase the frequency, the range of the transmission will be lower. So we need repeaters. Those are automatic repeaters, unintended repeaters in Hungary for the 2 meters band and for the 70 centimeters band. That means that the whole country is covered with 2 meter and 70 centimeter repeaters. We also have external connections with the neighbor countries, and you can see there are red line inside. That means that from that station, I am able to address that station immediately. So that communication line will be totally transparent. And the bandwidth, let's forget it, but this is, I would say, a fairly good bandwidth if you don't want to transfer films, large pictures. If you want to distribute information, that bandwidth is more than enough. I have to say, this is the bit rate, not the baud rate. What is the difference? Baud rate is the frequency of changing the statuses of the transmitter. If you have two status in the transmitter, your bit rate will be equal to the baud rate. If the transmitter is able to handle 4 statuses, that means that the baud rate will be half of the bit rate. If you have 8 status, the bit rate will be 1/4 of the baud rate. Actually, it was opposite. The baud rate will be 1/4 of the bit rate. That means that if I use a 50 kilobaud per second transmitter with 8 status, the result will be 200 bit per second transmission rate. AX25 can be replaced with TCP. In this case, the port, the traffic should be hijacked, is not the serial port but LAN port. The next steps are the same. The sound card will convert the bit stream to sound mix, and in the receiving side, the sound mix will be decoded by a fast Fourier transformation to bit streams. And the TCP protocol can be implemented in the background. In this way, not a big deal, we can replace a piece of wire. We can build connection between 2 TCP stations, but not a real internet connection. From the news, in Egypt, the internet was shut down. I think everybody has heard it in the radio. Internet is an enormous organizing power, so if you turn it off, the organizing power disappeared. So that was why they tried to turn the internet off. After 3 days, the Egypt internet started to work without the central part of the internet. So they needed only 3 days to re-establish the connection. How? Your internet service provider offers separated IP clouds, IPIs, and there is no interconnection between the separated eyes. And if you want to build the internet, you have to connect them together. That's the task of the border gateway protocol, which ensures a dynamic routing, and in addition, border gateway protocol ensures not to build loops inside the eyes, not to build loops inside the different connections. Dynamic routing, it's very good chance to build a secondary network behind the primary, because you can order prices, I would say prices, to the edges of that tree, internet tree, and BGP will select the lowest price way. If it disappears, it will select the second one. So if the provider stops that port, the BGP will stop that way, it will delete that edge, and will select the second lowest price edge. That will be a secondary communication. The internet connection will not be disappear. There will be a throughput degradation, but it will work. How many central routers are in Hungary? BIX is a very well-known central point. That was the building of the earlier Staki. the academic research institute. And now we have two other ones, but those are also connected to the BICS. That means that if you want to block the outgoing, the external connection, it's sufficient to block the BICS, and Hungary will be separated for the other countries. If you want to block the internal traffic, you only have to turn off these three central points, and the service providers will be separated. So it's so easy. But if you have a radio grid with TCP communication, it can replace the turned off systems. Yes, we can substitute them, but it depends on what we want to do. We can connect the eyes together. It's more than enough for text communication, for emailing, but it's insufficient for distributing films, musics, and so on. If you want an international connection, you need someone partner over the borders with the same configuration, radio-connected PC, and legal connection to the local network. And we have to teach our PC to act as a router and run the BGP. It's not a big deal. You can find several open source BGPs on the internet, and some of them can run in standalone mode, in a portable mode, so you don't have to install it on your machine. You can run it from a pen drive. Your PC should be a special router, at least with two legs. One leg is for the radio connection, another leg is for the international connection or the wide network connection. Three legs is a bit better because on the third leg you can supply your local network. One leg is insufficient. So it will be an uncontrollable network because you can install several secondary connections, several bridges in the network. It will not be visible for your service provider. It will be visible only when it starts to work. So that way you can bypass any firewall, any data diode. So it's a very dangerous mode of application. What you need is a pen drive with a standalone BGP, a two-way two-band radio, $40, and a piece of wire to connect the PC with the radio. This way you can bypass any firewall, any data diode. So I would say it's useful method and dangerous method. So when you install a radio-based internet, a radio-based backbone, you have to think about that problems. Some other tasks, not so hard. Bandwidth control. If you want to provide a full internet access, you have to exclude films, flash players, and so on. You have to resize the pictures for smaller ones. So you have to throw away that parts of the websites which is not contains real information. That function can be done on your router. the last mile problem. If a wired eyes of as a service provider is running, it's not a problem because you have to connect your radio backbone to the eyes, and everybody can be able to access the internet on the normal way. If the local wired network is also down, the wireless router with free access points can help to solve the last mile problem. How can you distribute this new technology? In Hungary, there are 3,600 radio amateurs with call signs. About 1/3 of them is able and ready and willing to run AX25. So there is a fairly large AX25 traffic in Hungary. If you give them an open source solution for the amateur TCP, it will be distributed in minutes. So it's not a big problem, but remains the legal issues. The legal issue comes from copyrighted material, protected material, bypassing firewalls, bypassing filters, bypassing data diodes. So the new technology, the new way of communication, the new chance of distributing information raises a set of legal issues. But this is not the task of the radio amateurs and not of the tasks of the internet users and service providers. It's a legal problem. So I hope that in Hungary, the TCP-based radio backbone will be up and run in a year. It's a very new technology with well-known components. We only have to put them together, and that means that in a short time we can have a radio backbone in Hungary. So it's not a cookbook. I would like only to provoke you to think about that way of internet communication, but I think it worth a think. Thank you for your attention.
If you have any quick questions, we have a couple of minutes for that. I don't know, there's a hand there. Okay, I have a mobile microphone, so you might want to come forward and then I can give you one, or you can just shout if you want.
Basically, my question is that is it possible to participate in the ham mesh routing without any knowledge of the ham radios working?
If you have the proper radio, it's possible. So you have to have a friend with the proper device and the proper piece of wire, and you can do it.